Okay, so guys, in this video, I just want to tell you that what is the chain rule, okay? And in the upcoming videos, you will be solving a couple of different questions which are related to the chain rule and how you can use it to find the derivative of some complex functions. Now, the thing is, why are we using the chain rule? We have learned the first principle method to solve for the derivative of any function. We also know some 5 formulas according to which we can find the derivative of a function given to us. But now, why are we wanting to know the chain rule to find the derivative? We already have two methods, then why moving to a third method? Well, in math, you have approximately 50 to 100 different methods to solve a question. And the more methods you have, the more opportunity you have to make the question easier, right? And when you go further ahead in this differential calculus series, you will find that the functions are becoming more and more complex, and it is becoming very difficult to find the find the derivative of the function using those 5 formulas or the first principle method. So now we will be using the chain rule. Now, what does the chain rule says? I have a function. Let's just say we have a function right over here. Now we have y is equal to x cubed plus 1 power 9. Now it says that this is a function. Okay, that's nice. But what is the actual notation of a function? It is y is equal to f of x, right? Which means that this thing right over here, this thing is my f of x. We know that y is equal to f of x, where x is the independent variable and y is the dependent variable, which is dependent on x. Now in the chain rule, we make this function, this x cubed plus 1, this in itself is a function, and this actually multiplied by 9 is another function, right? So we take this thing present over here and make it equal to some other third function. What do I mean by that? I will say that, let's just say any other function, g would be equal to x cubed plus 1. Okay, so this is what the chain rule says. Now how am I going to reach the derivative of the function? Okay, I have let it equal to g or whatever, some other third variable. Now how am I going to reach the derivative? I'm just coming to the point. But first, you can see that this has become y will equal to g power 9. And so now I have introduced a third variable into this function. And so how we can find the derivative? Well, we know that we have to find the derivative of y with respect to x, right? So dy by dx. But the thing is, we have introduced a third variable over here. So what you have to do, you have to find the derivative of y with respect to g, and then you have to find the derivative of g with respect to x. Multiply those things and you will reach the final derivative. So let's just do the same steps. First of all, we have to find the derivative of y with respect to g. So we have y is equal to g power 9. So dy by dg is equal to d by dg g power 9. And now let me tell you one thing. The thing which is present over here in the denominator is actually present over here on the left hand side of the equation. So you can see that we are taking the derivative of g in the denominator, and guess what? G is present on the left hand side of the equation. This actually proves that our equation is right. Another way to check that if you are applying the formula right or not. So the derivative would be simply 9g 8. Okay, and now what we have to do next, we have to find the derivative of g with respect to x. So g is actually equal to x cubed plus 1. So we have to find the derivative of g with respect to x, and we have dx x cubed plus 1. So we can simply write it as d by dx and x cubed plus d by dx 1. This is a constant, so the derivative of any constant is equal to 1, and over here we have 3x squared. So this is dg by dx. Now for the final thing, we have to put the value of g over here. What was the actual value of g? It was x cubed plus 1, x cubed plus 1 power a. That's the thing. And now we can simply use the chain rule. What is dy by dg? It is 9x cubed plus 1 or 8. And what is dg by dx? It's 3x squared. Now simply 9 3s are 27, x squared, x cubed plus 1 power 8. This is the derivative of this function. Okay, so I hope that makes sense. And now let's solve a couple of different questions according to this method in order to solidify our concepts on the chain rule. And remember, in maths, if you have to master any concept, the best way to do it is that you practice more and more questions related to that specific concept. Okay, so now over here we have a function root a minus x divided by plus x, and we have to find the derivative of this function using the chain rule. So how I can do, first of all, what it can also be written as a minus x, a plus x power 1 by 2, right? What I told you, the thing which is present inside the power, the thing which is present under the exponent, that is going to be my third function. So we have y. Now guess what? We have supposed that g is actually equal to a minus x divided by a plus x. So I can actually write y is equal to g power 1 by 2. Now for the chain rule, we know that we have to find the derivative of y with respect to g, and then the derivative of g with respect to x, and then we have to multiply those things in order to find the derivative of the final function. So let's begin. First of all, we have y is equal to g power 1 by 2, and we have g is equal to a minus x, a plus x. First of all, the derivative of y with respect to g, d by dg, g power 1 by 2. So what would be the derivative? It would simply be 1 by 2 g power negative 1 by 2, and I can reciprocate it in order to convert the exponent into a positive one. So 1 divided by 2 g power 1 by 2. Now stop over here. We are going to find the derivative of g, the derivative of g with respect to the derivative of x. Remember that the a over here is a constant, so we have to find the derivative of g with respect to x. So d divided by dx, a minus x, a plus x. Now guess what? It's the old beautiful division derivative question, so we can simply use the rules of division to find the derivative of this function. So we have this as fx, the first function, we have this as gx, the second function, and now we can go ahead. A plus x, d by dx, a minus x minus a minus x, d by dx, a plus, and in the denominator we have the square of the second function. And if you're unsure what was happening over here, you can check this video in order to master these 5 formulas related to the differentiation. A plus x, what have I told you, that a is a constant, right? So the derivative of any constant is actually 0, and the derivative of x is 1, but the x is actually coming with a negative sign, so the derivative would be negative 1 minus a minus x, and again the a is a constant, the derivative of x is 1, and in the denominator we have a plus x minus a minus x. I've just multiplied this negative sign with the term present over here, minus a, and again this negative sign multiplied by this term present over here, a plus x. Now we have a plus x whole square, this x is cancelled, we have negative 2a divided by a plus x, and over here 1 over 2, what was the actual value of g? Well, it was a minus x divided by a plus x, a minus x divided by a plus x. Now if you look at it for a while, you will see that this was the denominator, and this again is the denominator. Now the denominator of any denominator becomes the numerator, so it can be written as 1 divided by 2 a plus x, 1 divided by a minus x, 1 divided by 2. You see that the thing which was present in the denominator of the denominator of the denominator, it actually becomes the numerator, and this is a common rule. I can simply use the chain rule. Okay, so we have, so what was dy by dg? It was 1 divided by 2 a plus x power 1 by 2 divided by a minus x power 1 by 2. And what was dg by dx? It was negative 2a divided by a plus x whole square, right? So this 2 is cancelled. Okay, these all are being multiplied. So, and now we have negative a divided by a minus x 1 by 2. Now see, we have a plus x power 1 by 2, and in the denominator we have a plus x squared, right? And when the bases are same, the powers are added. Can it be written as a plus x power 1 by 2 multiplied by a plus x with a negative 2? Yeah, if I reciprocated, it would become negative 2, and when the bases are same, the powers are added. Negative 2 plus 1 by 2 would be 2, negative 4 plus 1, it would be negative 3. So it can be written as a plus x power negative 3 by 2, and again this is the negative exponent, so it would become negative a over a minus x power 1 by 2, and this thing would be reciprocated, it would become a plus x power 3 by 2. Okay, so I hope that makes sense.